Coastlines are dynamic places. They are constantly changing. Waves crash against the shore, tides ebb and flow, storms bring powerful forces to bear. These natural forces shape and reshape the coast. Coastal communities are built along these ever-changing shorelines. This creates both opportunities and challenges. We must protect these communities from the power of the sea. We must also preserve the natural beauty and resources of the coast. This delicate balance is where coastal engineers come in. Coastal engineers play a vital role in protecting and managing our coastlines. They are problem solvers, innovators, and guardians of these dynamic environments. Using their expertise, they design structures, develop strategies, and implement solutions to address the unique challenges posed by the constant interaction between land and sea. Their work is essential for protecting lives, property, and the health of our coastal ecosystems. The work of coastal engineers is becoming increasingly important. Climate change is causing sea levels to rise and storms to become more intense. This puts coastal communities at greater risk. Coastal engineers are at the forefront of developing innovative solutions to these challenges. Their work is crucial in helping us adapt to a changing climate and ensure the long-term sustainability of our coasts. Coastal engineers are the unsung heroes of our shorelines. They are the architects, engineers, and environmental stewards who dedicate their careers to understanding and managing the complex interactions between the ocean and the land. Their work is diverse and demanding, requiring a deep understanding of oceanography, hydrology, geotechnical engineering, and environmental science. At their core, coastal engineers are problem solvers. They analyze coastal processes such as wave action, tides, currents, and sediment transport to identify potential risks and vulnerabilities. They use this knowledge to develop innovative solutions that protect coastal communities, infrastructure, and ecosystems. Their work encompasses a wide range of activities, from designing seawalls and breakwaters to restoring beaches and wetlands. Coastal engineers also play a critical role in planning and developing coastal areas. They work closely with urban planners, architects, and developers to ensure that new construction is safe, sustainable, and resilient to coastal hazards. Their expertise is essential in designing harbors, marinas, and other coastal structures that can withstand the harsh marine environment. The work of coastal engineers is not limited to protecting human interests. They are also deeply involved in preserving the natural environment. They understand the importance of healthy coastal ecosystems and strive to minimize the impact of human activities on these fragile environments. Their work includes restoring damaged beaches, creating artificial reefs, and designing structures that mimic natural coastal processes. Coastal engineers employ a variety of methods to protect shorelines from erosion, flooding, and other hazards. These methods are essential for safeguarding coastal communities and preserving natural habitats. These methods can be broadly categorized into two approaches: hard engineering and soft engineering. Each approach has its own set of techniques and applications, tailored to address specific coastal challenges. Hard engineering involves the construction of structures that directly resist the forces of the sea, while soft engineering focuses on working with natural processes to achieve a more sustainable solution. Both approaches aim to mitigate the impact of coastal hazards. Seawalls are a common example of hard engineering. These robust structures are designed to protect the land from the relentless force of the ocean. These massive structures are built parallel to the shoreline, acting as a barrier between the ocean and the land. They are often seen in areas with high wave energy and significant coastal development. They are typically made of concrete, steel, or large rocks and are designed to withstand the full force of waves during storms. The materials used ensure durability and long-term protection. While seawalls are effective in protecting property and infrastructure, they can also disrupt natural sediment transport and negatively impact the surrounding environment. This can lead to unintended consequences such as increased erosion in adjacent areas. Breakwaters represent another widely used hard engineering technique. These structures are strategically placed to absorb and deflect wave energy. Unlike seawalls, which are built on the shoreline, breakwaters are constructed offshore, parallel to the coast. They create a calm area of water between the breakwater and the shore. These submerged or partially submerged structures are designed to break the force of incoming waves, reducing their energy before they reach the shore. This helps to protect the coastline from erosion and storm damage. Breakwaters can be effective in protecting harbors, marinas, and beaches from erosion, but they can also alter sediment transport patterns and create areas of localized erosion or accretion. This can impact the natural dynamics of the coastal environment. Soft engineering methods offer a more sustainable approach to coastal protection. These methods work in harmony with natural processes to enhance the resilience of coastal areas. Beach nourishment, for example, involves replenishing eroded beaches with sand dredged from offshore or other sources. This helps to restore the beach's natural profile and provides a buffer against wave action. This method helps to restore the natural buffer provided by beaches, protecting coastal development and infrastructure from storm surge and erosion. It also enhances the recreational value of the beach. While beach nourishment is generally considered a more environmentally friendly option, it is a temporary solution that requires ongoing maintenance and replenishment. Regular monitoring and periodic replenishment are necessary to maintain its effectiveness. Section 4. Rising tides, rising action, combating sea level rise. Sea level rise is one of the most pressing challenges facing coastal communities worldwide. The impacts are far-reaching and multifaceted, affecting not just the environment but also the economy and social fabric of these areas. As global temperatures rise, glaciers and ice sheets melt at an accelerated rate, adding more water to the oceans. This phenomenon is exacerbated by the thermal expansion of seawater, which occurs as the ocean absorbs heat. This, coupled with the thermal expansion of seawater, is causing sea levels to rise at an alarming rate, threatening coastal communities with increased flooding, erosion, and saltwater intrusion. These changes are not just future threats, they are happening now, affecting millions of people. Coastal engineers are at the forefront of developing innovative solutions to address the challenges posed by sea level rise. Their work is crucial in mitigating the impacts and ensuring the safety and resilience of coastal areas. They are working to design and implement adaptive measures that will protect coastal communities and infrastructure in the face of rising seas. These measures are essential for the long-term sustainability of coastal regions. These measures can be broadly categorized into three main approaches: accommodation, protection, and retreat. Each approach has its own set of strategies and applications tailored to the specific needs and conditions of the area. Accommodation involves adapting to the impacts of sea level rise by elevating buildings, constructing flood-proof structures, and implementing flood warning systems. This approach aims to live with the water rather than fight against it. This approach recognizes that some degree of flooding may be unavoidable and focuses on minimizing the damage and disruption caused by these events. It is a pragmatic way to ensure that communities can continue to function despite the challenges. Protection involves constructing barriers and other structures to prevent flooding and erosion caused by sea level rise. These physical defenses are designed to hold back the water and protect valuable land and infrastructure. This approach includes building seawalls, levees, and other coastal defenses to hold back the rising waters. While effective, these structures require significant investment and maintenance. While protection can be an effective short-term solution, it is often expensive and can have negative environmental consequences. The construction of these barriers can disrupt local ecosystems and alter natural coastal processes. Retreat involves moving people and infrastructure away from vulnerable coastal areas. This strategy acknowledges the reality that some areas may no longer be safe or viable for habitation. This approach recognizes that some areas may become uninhabitable due to sea level rise, and that managed retreat may be the most sustainable option in these cases. It is a forward-thinking strategy that prioritizes long-term safety and sustainability. While retreat can be a difficult and politically charged decision, it may become increasingly necessary as sea levels continue to rise. The choice to retreat is often fraught with emotional and economic challenges, but it is a crucial part of the conversation on how to best adapt to our changing world. Section 5. Gateways to the world, ports, harbors, and coastal engineering. Ports and harbors are the lifelines of global trade, connecting continents and facilitating the movement of goods and people across vast distances. They serve as critical nodes in the global supply chain, ensuring that products from all corners of the world reach their destinations efficiently. These bustling hubs of maritime activity are essential to modern economies, but they also face unique challenges posed by their location at the interface of land and sea. The dynamic environment requires constant adaptation and innovation to maintain operational efficiency. Coastal engineers play a vital role in the design, construction, and maintenance of ports and harbors. Their expertise ensures that these structures can withstand the harsh conditions of the marine environment. They are responsible for ensuring that these critical infrastructure projects are safe, efficient, and resilient to the harsh marine environment. This involves meticulous planning and rigorous safety inspections. This includes designing breakwaters and jetties to protect harbors from waves and currents, which can be particularly destructive during storms and high tides. Dredging channels to accommodate large ships, ensuring that even the largest vessels can navigate safely and efficiently. And constructing docks, piers, and other facilities necessary for loading and unloading cargo. These structures must be robust and durable to handle the constant wear and tear of port activities. Coastal engineers also play a crucial role in ensuring the environmental sustainability of ports and harbors. They work closely with environmental scientists to assess and mitigate the impact of port activities on local ecosystems. They work to minimize the impact of dredging and construction activities on marine ecosystems, employing eco-friendly practices and technologies. Design stormwater management systems to prevent pollution, ensuring that runoff from port areas does not contaminate local waterways. And develop strategies for managing ballast water and other potential sources of contamination. These measures are crucial for protecting marine biodiversity. As global trade continues to grow, the demands placed on ports and harbors will only increase. This necessitates continuous expansion and upgrading of port facilities to handle the rising volume of cargo. Coastal engineers will be at the forefront of developing innovative solutions to meet these demands, utilizing advanced technologies and construction methods, while also ensuring that these vital gateways to the world are developed and operated in an environmentally responsible manner. Their work is essential for balancing economic growth with environmental stewardship.